You might think database design is entirely about mapping out tables, columns, and fixed relationships. But an architecture that looks perfect on day one faces an immediate, invisible countdown. By the 6-month mark, most production systems are forced to answer whether they were built to endure or built to break. Those immediately start to age and warp under the weight of actual users. It isn't the passage of time that degrades these systems. They break because the business requirements shift and new edge cases crop up that no one anticipated during the design phase. This leaves engineers facing a frustrating paradox. We have to design highly precise, rigid structures to solve business problems that haven't actually occurred yet. If you build a schema that is too simple, it breaks the moment a new feature or complex requirement is introduced. But if you over-engineer the database to account for every possible scenario, the queries get bloated, system performance drops, and you slow down the team. This animated UI scale illustrates the architect's daily struggle. You constantly have to weigh the elegance of keeping things simple today against the unknown chaos of tomorrow. Database design ultimately requires an ongoing negotiation between current functionality and future unpredictability. Let's ground this theory by looking at a standard e-commerce order system. This diagram shows a typical setup: a table with ID, user ID, and order status. Then reality hits. A user cancels an item. Another requests a refund. A third requires an exchange. The status column shatters into multiple fragments to handle the new logic. Relying on a single static status field is meaningless when you are confronted with the fluid, messy realities of human commerce. To survive this kind of pressure, engineers have to pivot. You stop designing isolated tables and start designing a dynamic system of states. When trying to patch a broken schema, a common mistake is to simply overwrite the old data so the table reflects the present reality. But resilient systems act as a complete historical ledger. They capture what the data was initially, what it changed into, and the exact mechanism that caused the change. This animated timeline charts that approach. By mapping a single order's complete journey through multiple interconnected nodes, we log every state transition and event trigger, solving the chaos of those complex refunds and exchanges. Modern business decisions rely heavily on that historical context. If you overwrite the past, you destroy the data you need to build the future. Building systems that endure long past their launch date requires adopting a specific future-proofing mindset. First, think in events instead of static data values. A delivery is a historical occurrence, a specific point in time that carries its own context, rather than a simple Boolean flag in a table. Second, aggressively decouple your systems. You want to prevent an isolated change in one department from triggering a dangerous cascade across the entire database. Third, accept that your database schema is fluid. It will and must continually evolve. Fourth, deliberately design the architecture to accommodate partial failures. Real systems rarely collapse in a neat binary way. They fail in pieces. Combined, these principles form a strict framework for managing chaos. They ensure your database bends under the pressure of new business logic rather than breaking. Mastering database architecture requires a shift in mindset as much as a mastery of syntax. You have to learn to think like the business, anticipating and absorbing human unpredictability as it branches out over time. Coding tutorials teach you the idealized structure needed to build an app, but live production environments demand a mindset focused on survival. To build truly resilient digital infrastructure, an engineer has to stop chasing an illusion of perfection and start designing for continuous change.